Hey, math scholars. Yesterday we worked a bit on understanding the connection between percents and decimals and fractions. And so this is the page that I introduced to you yesterday, and this is the page that you're going to finish today and turn in. So let's go ahead and review a few of our concepts. So the key concepts over here, if you remember, are that a percent to a decimal, all you need to do to move a percent to a decimal is move the decimal point two places to the left. So this is the equivalent of dividing by 100. So you're going from percent, which means out of 100, and you're changing it to a decimal, which is a decimal is just out of one whole or out of one. So that's why we divide by 100. And when you divide by 100, you're moving the decimal point two places to the left. So we start out at 18%. If we move our decimal two places over, we get 0.18 or 0 and 18 hundredths. And the same thing is true when you move from a decimal to a percent. You have a decimal here of 0 and 73 hundredths. Well, remember, 73 hundredths is out of obviously a whole, but you have the whole broken up into 100 equal parts. So to get a percent, you're just moving the decimal to the right. So you're multiplying by 100 instead of by 1 to make this 73%. So that's kind of the important thing to remember. And then, of course, this is the visual model. So 18% or 18 hundredths. And so you can see here that here are 10 hundredths and then 8 more hundredths to give you 18 hundredths shaded in. So that's the visual model of that. So as we look at some of these problems, let's look at problem number 2, for example. So problem number 2 is a little bit tricky because it's over 100%. And yes, you can have percents that are over 100. So in this case, it's 145%. So how do you turn that into a decimal? Well, you move the decimal. You can't see the decimal place, but you know it's right here after the 5, and you move it 2 places to the left to make it 1.45 or 1 and 45 hundredths. So as a fraction, of course, this would look like this, 1 and 45 hundredths, okay? So that's how that looks. And then as we get down to the problems that you're completing today, you are going to be turning the percent as a decimal. So for example, this is a tricky one if we look at number 11. 11 is 1%. So you might be confused and think that this would be might be like as a decimal 0.1, but it's definitely not. It's not 0.1 because if you look at the decimal 0.1 or 0 and 1/10, well, 1/10 is 10 hundredths, right? And so this would actually be 10% as a decimal. So that's not what this problem is. So if it's 1%, remember we move our decimal place to the left to change it from a percent to a decimal. So if my decimal's here, I'm going to move it 2 places over. Now you don't list the 0 there, but there is a 0 there. And so this would be 0 and 1 hundredth. So it would be 0.01. That is the decimal equivalent of 1%. And so you can see, again, this is the hundredths place. So you have to make sure that your decimal on any percent goes to the hundredths place. Now let's take a look at this one, number 9. So this is 32.5%. What is this as a decimal? Well, as a decimal, this would actually go to the thousandths place. So remember, we move our decimal 2 places over. So this would be 0 and 325 thousandths. So because of that 0.5%, that's where we go to the thousandths place on our decimal. So I hope that helps you finish 6 through 13. Again, 14 through 17, you're just changing it from a decimal to a percent then. So you're moving the decimal the opposite way. So you're moving the decimal 2 places over. So this would actually be 0.1%. So that's a very small number, very small percent. Number 18, 19, and 20. What percent of the circle graph is represented by the yellow region? So all you're going to do is if you just think about these as percents, so this whole circle graph, remember, represents one whole. So if that represents one whole, you're going to have to do some subtraction to figure out what that missing area would be, missing region. So this is 35 hundredths if we want to look at this as one whole, or if the pie chart, if we want to look at the pie chart as 100%. So if the whole thing was filled in, it would be 100%, which is equivalent to one whole in this case. So this is actually 35%. This is 25%. So what would the missing region be? Well, if you start out with 100 and I can add these together. So the blue and the red section added together, 35, this would be 45, 55, 60. So both of these sections would be 60% of the chart, of the graph. So if that's 60%, what is 100 minus 60? I know that 100 minus 60 is going to be 40. So that means that this section, the yellow section, is 40%, or if we look at it as a whole, 0.40 or 0.4, 4/10 or 40 hundredths, because those are equal. So you're going to do the same thing here, except again, you have all of these percents or decimals that you need to subtract from the whole to figure out the missing region. So that's how you would do those problems. I want you to do those on your own. And then if we scroll down a little bit more, you have two problems here to work out. And so show all your thinking and show all your work. Let's look at number 21. You have set aside 2/25 of your monthly budget for clothing. What percent is this? So 2/25 of your monthly budget. So that means that you're going to do 25th or 25%, and then another 25%. So you set aside 2/25 of your monthly budget. All right. So what would those two percentages be? That's a lot of money for clothing, but what would those two percentages be when you add them together? Number 22. 87% of the students in your class do not plan to attend summer school. What percent of your class plans to attend summer school? So what you're going to need to do is if 87%, so again, if you think of this as a pie chart, and this represents 100%. So if 87%, and I know that that's going to be more than half, right? And that's actually going to be more than 3/4. So if this is 87%, what is this missing region going to be? So you're going to simply start with 100 and subtract 87%, and that's going to tell you what that missing area would be. So I hope this helps for you today. And make sure you finish this, turn it in, and I hope you guys have a wonderful rest of your day.